Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and happy. Okay, so today we are going to summarize our chapter. The name of the chapter is Area of Parallelogram and Triangles. So we have studied the concepts, we have done with the numericals and the theorems. Okay, there were so many theorems, so many numericals, and we have done it all, and it is like quite easy chapter. Okay, so there was some few concepts. We are going to revise these concepts in this summary so that you can have a quick revision of this complete chapter in this one shot. Okay, so let's get started. So the very first point of it, right, is in this chapter we talked about the area. I've told you what the area is. If these are the lines, okay, so these lines are confining a region, and this particular region, this closed region, is what? Area. Okay, so the same as area of a figure is a number in some units. In numbers like 28, or let's suppose 1056.28, in some units may be any unit like centimeter, meter, but that should be in square. Okay, square units. In some units associated with the part of the plane enclosed by the figure. Now this word plane, this is important. This enclosed by that figure. Okay, this is important. And in some unit, a number. Okay, this is important. So these are the keywords, and you are having the definition of area in mathematics. Okay, now the next thing is two congruent figures have equal areas, but the converse need not to be true. What we have studied, if we are having two figures, okay, and these figures are what? Congruent to each other, then the area of these two figures will be the same. That means if you are having two circles, if these two circles, that means what? They are having the same radius. If this is the R1 radius and this is the R2 radius, then in this case R1 is equals to R2. That means these two circles C1 and C2 are congruent to each other. That means area of C1 circle and area of C2 circle are equal to each other because they are congruent. Okay, but if the area is if the area of two figures are same, let's suppose it's a square here, it's a circle here, and it's a square. The area of it is 52.5 centimeter square. Okay, and area of it is also 52.5 centimeter square. It can be, okay, so it can be possible, it can be possible. Now, are these two figures are congruent or not? These are not congruent to each other. That means converse is not true. Only the figures that are congruent will be having same area, but the figures will be having same area need not to be congruent always. Okay. Next, if a planar region formed by a figure, T is made up of two non-overlapping planar regions. Let's suppose it's having a T shape here. It's having two planar regions. The one is this part, which is represented as area P, and the second is area Q. Now in this case, area T will be equals to area P plus area Q. The only condition in that is that area P and area Q should be non-overlapping. Okay, so this is the important word here. P is not overlapping with Q, Q is not overlapping with P. Similarly, if you are having another part here, and let's suppose this is the area R, then the area T will be equals to P plus Q plus area R. Okay, is that clear to you, students? Okay. Now, next, two figures are said to be on the same base and between the same parallels. In what case? If we are having two parallels, okay, and the base of two figures, let's suppose I'm having a triangle here. Now it is A it is B, and it is C. Now AB is the base, and the other point is situated on the parallel, these two parallels. Now if I'm going to construct a trapezoid here, okay, so this will be ABCD is a trapezoid here. Now in that case, having the same base AB and between the same parallels AB and DC, so that will be called as two figures having the same base and between the parallels. Why we were studying that? We studied that because we are having some relation in areas of triangles in each other, triangles and parallelogram and parallelograms. Okay, so is that clear? So it's saying that two figures are said to be the same base. This is same base, and between the same parallels, if they have a common base, and the vertices or the vertex opposite to the common base of each figure lie on the line in the base. The example is, this is the PQ and this is the RS. These are two parallels. Now if I'm having this base A1, A2, and here I'm having these points B1, B2, B3. Let's have the same base AB, A1 and A2. Okay, I can make this triangle over here. I can make this triangle over here. Okay, I can make a parallelogram here. Let's suppose these two lines are parallel. Okay, so I can make a parallelogram here, or I can make a trapezoid here. Okay, so the trapezoid will be this. All right, so these all figures will be said as between the same parallels and having the common base. If I'll be making a triangle like that, it is not touching this. The point is not this point. Let's suppose this is D point. Then this D point is not the parallel PQ. Though it's having the same base, but it's not having the between the same parallels. Okay. Now parallelograms on the same base or equal bases and between these same parallels will be having the same area. That means will be equal in area. That means if we are having these two parallelograms here, let's suppose we are having this base AB, okay, and I'm having a parallel, I have a parallelogram. Let's suppose it. This is the first parallelogram, and I'm having this base, okay, and here it is the second parallelogram. Now the area of AFEB parallelogram will be equals to the area of AEDB parallelogram. Is that clear to you? Because they are between the same parallels, okay, and they are having the common base. And if we are having the equal base, what does that mean? If AB is equals to BC, in that case, if I'll draw a parallelogram like that, let's suppose this and this, okay, so now FECB is another parallelogram. They are having same base? No, but they are having equal base. That means this parallelogram FECB will be having the same area as the area AEDB or the area AFEB. Understood? Okay. Next, area of a parallelogram is the product of the base and the corresponding altitude. We have done it like if you are having this parallelogram and you are having this ABCD as the vertices of the parallelogram, then what will be the area? If we draw a perpendicular here and we'll name it AM. Okay, so in that case, that perpendicular and area of parallelogram. This perpendicular and the base of the perpendicular, in this case the perpendicular base is DC. Okay, so that will be going to the area of the parallelogram. Okay, you can take any side as a base and draw the perpendicular. Okay, now next, the parallelogram on the same base or equal base and having equal areas lie between the same parallels. Okay, so in that case it was saying that parallelogram on the same base or equal has having equal areas and lie between the same parallel. Okay, if we are having Okay, we have done this, right? Now, if the parallelogram and a triangle are on the same base, now what is the relation between a parallelogram and a triangle if they are having equal bases or the same base? So, if this is the A, B, C and D point, and we are having this parallelogram ABCD. Okay, so this is the parallelogram here. Right, and we are having some point here, and we'll be having this triangle AED. Then the area of the triangle AED will be half of the area of the parallelogram, this ABCD. Okay, now here this is the triangle and this is the parallelogram. Understood? Having the same base. Again, if you're having the parallelogram and the triangle not in the same base but are having the equal base and between the same parallels, that time this is going to be also true. The area of triangle be half the area of the parallelogram. Okay. Now next, triangles on the same base and between the same parallels are what? Equal in areas. So if you are having two parallels, okay, now if you are having AB is equals to BC, okay, or if you are having this AB is equals to this BC, in that case, if you are having these points D, E, F here. Now, talking about the triangles made by the equal base or same base. So, let's pick this one, AB as base. You're having this triangle ABD. Okay, this will be having the equal area as that of this triangle. The triangle ABE. These will be having equal areas. Okay, now I will talk about this BC. This BC is the same base as AB. So anything like that will be having the same area. Okay, again I can have these another triangles over there. Do I have more colors? Okay, so if I'm having this triangle, again the base is equal to that. So pick any color triangle like yellow or red, this purple one or this blue one or this green one will be having the same area of the triangles here because they are having either equal base or the same base. Okay, and they are between the same parallels. Okay, but if I'll draw a triangle like that, the vertices is not here on the parallel, so these are on the same base but not in the same parallels. That means we are having a triangle that must not have the equal areas that of all. Okay. Now, next, area of triangle is half the product. What is the area of triangle? This is very clear to you guys. If this is what you call a triangle is, okay, let's suppose name it ABC. Okay, so we'll be having, let's suppose a perpendicular to it D, a perpendicular to it E, and a perpendicular to it F. Okay, so what will be the area of this triangle? Area of triangle ABC, half base height. Now in the three cases, if we will be taking the base as AB, then this time in the case of AB, CF is the perpendicular, so that will be CF. This will be same as the area when we're taking the base as AC. So if you are going to take AC as the base, you'll be having this EB as the perpendicular. Okay, now if you are going to take the remaining side, which is BC, as your base, then you are going to take AD as the diagonal. Okay, and I can color it for you. Like this is the pair of base and the perpendicular for the area. This is another pair of it. Okay, this line is that. Okay. Okay, the third pair is here. Understood? Okay. Now, my dear student, the next point is triangles on the same base or equal base and having equal areas lie between these same parallels. We have talked about this. If they are between the same parallels and they are between the same parallels and they are having the same base, then that time they are going to have equal area. We are just reading the converse of it. If triangles on the same base, okay, or equal base and having equal area, they will be lying in the same parallel. The converse is also true. Next, a median of a triangle divided into two triangles of equal areas. This is going to be very important, students, because we have done some questions based on it too. Okay, if I am having these vertices A, B, C and I am having some median of it is here. The midpoint of AB is D, the midpoint of BC is E, and the midpoint of AC is F. Now, we are going to have medians, vertices. We are going to have the medians. They will intersect at the same point. Okay. Now, what I am going to tell you is that if you are having this median part here, okay, if this is the median here, so this area and this area are going to be equal. Median divides a triangle into two equal areas. So this area will be equals to this area. Next, if you are having this DC as your median, then this area will be equals to this area. Okay, done with that. Now, if you're having this FB as your median, this area will be equals to this area. So median divides the triangle into two equal halves, in two equal areas. Okay, understood? Okay, next. So this was the complete key points of the complete chapter for us. What was that? The area of parallelograms and triangles. We have discussed the important properties, and that had came with the some extra things like area of parallelogram, area of trapezoid, area of a triangle, and we have studied it too. So I hope you're all set with this particular chapter. Let's meet in another chapter with some new concepts, with some new theories. Okay, enjoy your life and take good care of yourself, students. Bye bye.